Hello, Astronomy. Welcome to Chapter 13. This is the last chapter of our book. Can you believe we finally made it? We're done talking about stars by themselves now. We're going to look at the stars in the bigger picture of our galaxy, specifically our galaxy. Now, some of the stuff we learn here, we could use for other galaxies, but the developments and things that we go over this chapter are specifically for our galaxy. Spam callers trying to interrupt my class. How dare they? Let's begin. So, section 13.1 says the sun is located in the disk of our galaxy, about 25,000 light years from the galactic center. Now, there's a couple words in here that we're going to have to go over in the course of this PowerPoint. For example, the disk of our galaxy, the galactic center. Like, what do those words even mean? Well, we're going to get to that soon. Let's look at what a galaxy is. Oh, damn, we didn't even talk about what a galaxy is. It's an immense collection of stars and interstellar matter, far larger than a star cluster. We might have mentioned like a couple stars hanging out next to each other, but a couple of stars hanging out next to each other does not compare to the size of a galaxy at all. Galaxies are huge. For example, our sun is one of several hundred billion stars in the Milky Way galaxy, which is observed from Earth as a wispy band of light stretched across the sky. If it's late enough and you're in a place that's far away enough from a city, you can see the Milky Way. And lots of ancient cultures revered the Milky Way as something, if not holy, then something otherworldly. And that's just part of our galaxy. It's the only part we can see. There's several hundred billion stars in the galaxy, and our star is just one of them. And you can only see some stars, which should give you a scale as to the type, the size of the thing we are talking about right now. That is our galaxy. So this is probably a little bit better than you could see with your eye. But this is the kind of band we're talking about. If it's late enough and dark enough, and you're far away from a city, you can see a band of a lot more dense stars somewhere in the sky. I don't know. It's just incredible. If you ever get a chance, I actually did not ever get the chance until last summer to actually see the Milky Way at night with my own eyes, and it was pretty cool, to be honest. I was sitting out camping around a fire. The fire kind of died. You look up, and there's just this massive band of stars, and it's an experience. Our galaxy is, though, filled with visible light-obscuring dust. Now, those hyphens are there for a reason. It's visible light-obscuring dust, meaning the dust isn't visible. The dust is obscuring the visible light. Okay? It's as if our galaxy is a bunch of stars, but in between all the stars is a lot of nothing and a lot of dust. And that dust is pretty good at blocking light, visible light, like the stuff that we can see. So when we look up at night, there's actually quite a bit of stars that we can't see because of that dust. Here's some diagrams of the Milky Way. If we are here, this is kind of what we can see. It looks a little weird because they're just like taking the sky and stretching it into like this weird cylinder. This is not an actual picture of our galaxy because there's no way we have ever been outside of our galaxy. Nothing that we've ever sent has made it outside of our galaxy. Not even like radio waves or anything like that. But this is what we think it might look like. This is also what we think it might look like from the top down. Our galaxy has two major arms and several shorter segments, all spiraling out. But there's a lot of dust in this thing. A lot of dust and a lot of stars. And the dust is actually stopping us from seeing quite a bit of the stars. So the problem is, if we're trying to look around and find out where we are in the galaxy, but all we can see is a bunch of dust, how do we know the shape of our galaxy? Have you ever thought of that? You might have seen pictures that it's like a spiral, but how do we know that if we're inside of it? And I'll give you another example. Let's say you're in a gigantic crowd of people how do you know if you're in the center or not? If you've ever been in a big enough crowd of people, you can be walking and it seems like there's no way out, and all of a sudden you just pop and you're outside of the crowd. But there was no way of you knowing if you were in the center or close to the edge when you were actually in the crowd. That's how it is for us in our galaxy. If you just look around, we're not exactly sure what direction is the middle of our galaxy. And the way we do that, or the way we found out, is by something called globular clusters. So what these are a class of stars that are technically associated with our galaxy, but they lie just outside of that disk. They're a little above or a little below our disk. Because of that, they're outside of the dust clouds, and they can help us kind of, almost like little lighthouses, tell us where the center of our galaxy is. So if you're driving at night and there's a bunch of fog, you won't be able to see anything. But if you could look up past the fog and maybe there's a building with like a light on, you can easily see that, and you can kind of use that to get your bearings. We do the same thing in the Milky Way. If we're in the middle of all this dust, we can't see anything. Like this star over here, there's all this dust blocking us. But if there's a star just above the disk, outside of the gas, outside of the dust, then we can see those stars and say, hey, I know where that star is. So we can just head towards there, and that would be the center. This is a globular cluster called globular cluster M80. It looks pretty brilliant, actually. But there's definitely not a couple 100 billion stars like our galaxy has. Our galaxy is surrounded by a halo of these things. A galaxy is surrounded by a halo of globular clusters containing either RR Lyra variables or Cepheid variables. Now, these two words, they kind of just throw them at you in this PowerPoint like you should know what they are. They're groups of stars. Okay? So like this is globular cluster M80. This is the type of group of stars. This is just one group of stars, but we have classifications of RR Lyra and Cepheid. And using a bunch of math at those particular groups of stars, because they give us a lot of information, we can tell how far those specific groups are. And using those as our little lighthouses, we can detect where most of them are. Now, these two groups of stars, the only thing you need to know is they follow a period luminosity relationship, which means they're not pulsars, but they do get brighter every once in a while. And that's like all the information we need to know. They're little stars that get brighter and dimmer and brighter and dimmer over time. We can measure it, we can do math at that and find out how far away they are. And that's about all you need to know about the Cepheid and the Lyra. Here's what we're talking about. They get brighter and then dimmer and then brighter and then dimmer. But they're not pulsars. But they do act as convenient little markers for us to be able to tell how far away certain things are. What we found out by studying all these little lighthouses out there is that the globular clusters are not evenly around us. It's not like there's one, like they're in all directions from us. Most of them are in one spot. And that idea, combined with some other stuff we're going to learn, lets us know where the center of the galaxy is. Most of these little clusters are around the center of the galaxy. So let's go back to being in a crowd. You're not sure which way is around, but let's say you know that in the center of the crowd is a balloon stand. So you're standing in a crowd, a bunch of people about your same height are standing there, but you'll know that where you can see the most balloons is probably going to be where the balloon stand is, right? Because the balloons float a little bit higher than the people, so you can look and say, okay, I see the balloons over there. That's probably the center. That's kind of what we're doing, except with stars. We're not looking in the galaxy. We're looking just above it at all the stars right above it, so we can say, all right, well, most of the clusters are over there, so that must be the center. Now, if astronomers observed that all these clusters were evenly spread across all parts of our sky, what would we assume? Well, in that case, we would assume we would be in the center. Right? If all the globular clusters are evenly placed around us, then it's like we're in the center looking out at everybody spread around us. That is not what we see, though. We definitely see it grouped on one side, so we know that over there is the center, not where we are. Oh wow, that's it for section 13.1.